here. I am Arun Gupta, and with me today there is Bailey and Liam from Cosmonic. I'm super excited for them to be here. As I said, my name is Arun Gupta. I work for Intel. I lead the open ecosystem team here. These are Friday open source discussions. And really, the main thing here is I've been talking to a lot of wonderful people all across the world, and I thought, gosh, that's very selfish. I'm only talking to them one on one. And these are so wonderful conversations. I should be sharing them with a lot more people. So I just want to thank Liam and Bailey and how they set me up quickly with Restream. And I'm loving this tool absolutely. So there we go. So Liam and Bailey, welcome to the show.
Thanks,
Hey,
Arun.
happy
Great
to
to be
be
on.
here.
Exciting. So today we're going to talk about WebAssembly. It's been a really hot topic more recently. What WebAssembly is, how is it used, where it came about to be, and we're going to keep you on the nerves. We got some exciting live demos that we're going to show as well. That makes it that much more exciting as well. So, all right, let's get started. Um, let's start first right away. First of all, what is WebAssembly? What problem is WebAssembly solving?
I'll take that one, Liam. I would say that WebAssembly is a compilation target that many different languages can target. And what comes out is a binary file that's portable. It can run across different operating systems, different CPU architectures, and that's really valuable. But it's also really tiny because its original use case, its first use case, was for running in the web. And there in the web, you've got to download something, and users are impatient, so they want it to download really fast and start really quickly. So WebAssembly is perfect for that case. I call it a bunch of numbers in a trench coat because what is inside the WebAssembly binary is really a bunch of numbers, like I32s, and that is basically pure compute. And that's one of the reasons why it's able to run just about anywhere. You couple that with a WebAssembly runtime, and the WebAssembly runtime is that platform-specific piece. But I like how Liam talks about it too.
So, Liam, how do you talk about it? You got
Oh,
to
Liam,
mute
we
yourself.
lost your audio.
No, I apologize. I lost my mute button. I'm up here. There's a 20-mile-an-hour wind rolling in, so I was afraid I was going to interrupt your three integers in a trench coat explanation.
What you're saying
I
is the scene behind you is not a virtual background.
no, this is actually a real background today. I'm up in northern Michigan. I've got a place in Traverse City. It's my last day, and then we head back for school time and back to Washington D.C.
Excellent.
But it's always all WebAssembly all the time, regardless of where I'm at. And when I think about explaining WebAssembly to the executives and to higher level personas, I think it's best just to think of WebAssembly as the world's smallest virtual machine. Like a lot of technologies, as Bailey said, it was originally designed for the web. Think of the original vision or promise of even Java or later Flash or one of the other technologies that gave you plugin specific technology. The difference here is that WebAssembly is an open W3C standard that already runs on all of the major browser platforms and edge devices. And it's already being adopted by teams all around the world to deliver amazing experiences. One of my favorite examples is Amazon Prime Video. They support over 8,000 unique devices, Android, iOS, Samsung TVs, LG TVs, all through the magic of this tiny little virtual machine. But as Bailey mentioned, this virtual machine is a little hard to use. It's numbers in and numbers out. And that's where open source like CNCF WASM Cloud and upstream from there, our company Cosmonic come into play. What we do is we build developer tools and experiences to help developers take advantage of this powerful new open standard very quickly and innovate faster in their environments and in their organizations.
Awesome. And we will definitely talk a lot about WASM Cloud. So let's dig a little bit more into the introduction of WebAssembly. So you guys said this is a binary code, and also it's a compilation target for languages. How does the process work? Can I write in any language and then say, hey, convert this to WebAssembly, and then it goes over there? Is there a predefined set of languages? So talk me through that developer ecosystem.
Yeah, all the top 20 languages, about 17-ish of them have some level of support for WebAssembly, but that level of support is varying. There's languages that are statically typed, like Rust and C and C++ that have excellent production grade support. There are other languages that are up and coming, like the latest Go release has a WASI Preview 1 target. We haven't quite talked too much about WASI yet. It's important in that it's the WebAssembly systems interface, so it lets us take the WebAssembly module and run it outside of the web. However, to answer your question, there are a lot of different languages, and they do have to know about how to compile to WebAssembly to be able to support it.
Yeah, I'd pick up there, and I would really, at the highest level, I'd maybe group them into three targets. There's the static languages, like Bailey mentioned, C, C++, Zig, Rust, that have great support. They translate very well to the WebAssembly instruction set. On top of those, we have a set of interpreted languages. These are languages, think like JavaScript or .NET, which launched with early support for WebAssembly, and there's increasing support for Python, for example. Those languages require a little more. They'll bring the interpreter with them into WebAssembly, and it results in a WebAssembly module that's a little bit larger. And then there's a third set of languages that are maybe a little bit more distant, like some of the languages that run in the Java ecosystem. There's early successes with things like Kotlin, but Java itself is still on the way when we think about it. What's truly amazing, though, is that when we build things into WebAssembly, we're using this new standard in WebAssembly that's called WebAssembly components. And the easiest way to think about these is if WebAssembly is our CPU, components are like building blocks that we can use to build an application out of. They align to a standard that's called WASI, the WebAssembly System Interface, and think of that as the portions of your operating system or your POSIX environment. And rather than having a giant monolithic POSIX ABI, WebAssembly's taken a really innovative approach by giving you these smaller little ABIs that then, much like in the microservices world, we can enable things like permissionless innovation and the ability to sort of minimize what we support. It sort of plays to the larger value props of WebAssembly. At the highest level, WebAssembly starts with these first principles in mind. It's deny by default. It is really small. It's really fast. And it gives us a bunch of security propositions that other approaches that are 20 or 30 or 40 years old don't really bring to the table. Bailey, is there anything you'd add to that?
I love that explanation. Yes, so that's happening within the WASI working group of the W3C's community group around WebAssembly, and I'm a co-chair there with Pat Hickey, and we're pretty excited because this first set, basically, that lays that foundational set of primitive types that we believe everybody's going to begin building applications out of, is going to be available this fall. So we're really nearing that first release, and we call that release WASI Preview 2.
Fantastic. So you're telling me a lot of this work is happening out in W3C, the working group that you talked about. And I want to dig a little bit deeper into WASI a little bit later as well. But I'm amazed 17 out of 20 languages have some support for WebAssembly, which is awesome, actually. Now, WebAssembly, the standard itself was created a little while ago. What is gaining traction? Why is it becoming so popular and hot more recently, though?
Bailey, would you mind maybe extending that a little more and maybe tell a little bit of the history of WebAssembly? I mean, I think you one time called it the greatest hack of all time.
I did. Alon Zakai and some other engineers at Mozilla created ASM.js, which is really the precursor to WebAssembly. And I first started doing my own hacking on top of ASM.js in around 2012. And 2015 is when the WebAssembly design began. But ASM.js was that initial proof point of how to take legacy code, legacy applications, or rather just really languages that are in C and C++, and bring that to the web. But also bring it to the web in a way that is still sandboxable and safe and doesn't have all of the flaws that we've seen from other different types of plugin models that came before. And so that was one of the key things that were enabled. I remember Autodesk made a demo then. Adobe had several demos. I worked at a company called SAS, and we were bringing forward our data visualization library into the web. And it was a huge unlocker because everybody at the time was trying to aim for HTML5, but we also saw the web as like that final edge where our users are running. And finding a way to write and performant and high level code and bring that to the web. JavaScript wasn't the best language to write in to do this type of complex applications. Now we have TypeScript and it's hugely advanced there. But it's really nice to be able to write in a language that is also portable. So not just running it in the web, we were also taking that exact same code that we were running. Autodesk and Adobe were doing the same thing and running it on desktop applications across different operating systems and platforms.
That's beautiful. 2012 is when you said ASM.js was working and the standard itself was creating 2015. That's still a long runway, essentially. What is making WebAssembly hot now? Like for the last year or two, I've immediately seen a lot of traction picking up around WebAssembly. What is making it hot now?
I'd say in the cloud native space, the value props of something that is fast to distribute, right? If you think about downloading a tiny unit of compute in the web, you want that for large orchestration and large clusters and being able to bring it to the CDN edge. You need something that's really tiny. But you also need it to be fast, and we also want it to have the right level of sandbox. And so if you look at the main properties of WebAssembly, you'll see that, oh, wow, this is a perfect use case for what we call cloud native today. Liam, do you want to add to that?
Yeah, look, I would take more of a market driven approach to this. The last decade, Arun, was really this great lift and shift into the cloud, and markets make movements. Everybody wanted to get out of their own data centers and increase the abstraction of technology. Stop building their own capital investments. The first advantages of infrastructure that's elastic, so you can innovate faster. But the next decade is dominated by a different theme. The enduring theme that we're entering now is bringing our compute to the data. And that means that we want to run our code closer to users for performance, for security, for privacy, for regulation. And when we start to think in those terms, we suddenly have different requirements for what is the abstraction that we have. Developers today still want to go faster. And even with the increasing abstractions from virtual machines to public cloud to containers, there's still a lot of common complexity that's left in the environment. So I think what's driving WebAssembly forward is that WebAssembly as a standard and as a community is solving those challenges for developers. When we talk about enabling multiple languages to collaborate and work together, what that unlocks for enterprises and developers are all of those languages and silos that they've been stuck in before. The ability to take frameworks like Python or all the pandas that you have and combine that wonderful user experience with fast and performant Rust or C++ code, that's game changer for an enterprise in going faster. When you think about the idea, the 95% of common complexity, we all know that while it's free software, the cost of free is very high. The cost to maintain it, the cost to keep it up to date. Most big enterprises, especially for highly regulated, have turned their developers into boilerplate farmers, where they're simply updating all the yellows and reds and turning them green again. So WebAssembly is that technology that's just meeting that time and that place to give developers what they need to innovate more quickly. Nobody really cares about WebAssembly, and I think much like Linux or the public cloud, WebAssembly will continue to fade into the background as part of a deployment experience. And we see it being adopted not just by early stage startups like Cosmonic or open source communities in the CNCF like CNCF Wasm Cloud, but edge providers like Fastly and Cloudflare. Their CDN for microservices, if you will, is all based on WebAssembly underneath the hood because of these exact same reasons. And more importantly, for that higher enduring theme about bringing our compute to the data, moving closer to the users.
That's beautiful. The way I'm understanding and parsing the information is seems like cloud and cloud native was really priming the pump. And now that cloud native is sort of a given, WebAssembly just quickly shines up right there that, yep, you need a faster microservices based architecture. WebAssembly gives you that. The language adoption is happening and it just kind of rolls in right there.
Yeah, I would say if we wanted to do a compare and contrast between where we are today with containers and WebAssembly, I would highlight maybe three problems that cloud native and container paradigm really suffer from. The first I just mentioned is that all of the compile time dependencies. We take a snapshot of our libraries at compile time and embed them into a container, versus WebAssembly platforms that have the ability to load the most up-to-date and common requirements at runtime. The second one is the cold start problem. The cold start problem with containers is that even highly optimized or from scratch containers can take a half a second or longer on a Lambda case, depending on the framework you're starting with, in order to start. So we need to have a large amount of our compute already pre-warmed. WebAssembly is so small that the cold start time is measured in microseconds, 5 to 50 microseconds. And to be interactive, you have a time budget of 200 milliseconds. So the ability to cold start per invocation is very powerful, or to scale per invocation is very powerful. And the final reason I'll call the lower bound of Kubernetes, and that's that as we want to serve more and more global audiences, we have to run more and more compute horizontally. And if that means that you're a large enterprise with a global audience, you're not running in one single region or one single cloud. You're running across dozens of clouds globally, and oftentimes you're required to run in different clouds. For example, running in Asia, or increasingly for regulatory reasons, having to keep certain data in certain places. And this is not averse. I think, like many great things in life, WebAssembly and Cloud Native are better together. You can run WebAssembly directly on Kubernetes or in a container, on a virtual machine, in a public cloud, all the way, turtles all the way down. And through frameworks like CNCF Wasm Cloud and Cosmonic, it's compatible with but not dependent upon. You can also run it directly on edge devices, and I hope we're going to do some live experiments, some live demos, and we're going to see how that goes on the call today.
Fantastic. So what I'm hearing is, yes, like any technology, cloud native has also challenges, but WebAssembly kind of shines up really to solve those challenges. Compile time dependencies, cold start, lower bound of Kubernetes, as you said, and it really fulfills that gap right there. And because cloud native is so prominently and pervasive across the industry, WebAssembly is now shining up a lot more in that realm.
Yeah, I think it should be important, though, that maybe Bailey, you could speak to. WebAssembly is still an early stage technology, and one of the things that we do on a daily basis is help engineers to adopt WebAssembly, and that often means understanding where the weaknesses are in WebAssembly and what does the real roadmap look like. Maybe Bailey, would you mind giving us your perspective on the maturity of WebAssembly? And I know you even started this spreadsheet for 2 events we have upcoming about the types of things that are easy to port to WebAssembly, the types of things that may be a little bit harder to port to WebAssembly. Maybe talk about why.
Yeah, okay. So there's a set of things that are happening right now in this space. There's the core WebAssembly specification. That's stable. It reached MVP in 2017, and then in 2019 it became the 4th language of the web. That was when it was officially standardized by the W3C. Now, there are a number of other work streams that are working on enhancing just the WebAssembly core specification, including adding WebAssembly threads. That's something that we're really looking forward to use outside of just the web, where browsers have access to web workers and they have an implementation of using threads there. And so if you're using basically JavaScript glue, you can take a WebAssembly module and run with threads today. But a lot of people are interested in this cloud native case, being able to run server side. And so by pushing that type of knowledge into the WebAssembly core specification, then we can take advantage of it in any environment. And so that's one key work stream. And so if your program relies on threads, that's probably not something that works well today. It might not compile. Then there's this next level. There's this level of activity that's happening that isn't yet a standard. It's in a proposal phase. That's WASI. We've talked about that a little bit. But what WASI is actually building on top of now is called the component model. The component model is that piece that Liam was talking about that lets us link together WebAssembly components that were compiled from other languages. And that specification is really powerful. So it gives you language interoperability. it gives you this property that we call virtualizability. Because we know the imports and exports of what goes into this component, I can choose to give it something like a virtual file system, thus enhancing the sandbox capability of a normal WebAssembly module. And that's really exciting because we can build entire platforms on top of this technology. And I think WebAssembly components are that piece that we're getting really close to being able to build real things on top of it. And that's probably a lot of what's building some of the hype that's happening, at least this year, because it's adding so many new capabilities to the WebAssembly ecosystem. And so the chart that Liam was talking about is that I wanted to be able to come up with dependencies that a lot of people depend on. So when you first say, okay, I want to build something in WebAssembly, and you're writing your own first-party code, that's fine. You can almost always find a way to get that building. But when you start looking at your average application where 85% of the code isn't your own, those dependencies may need to compile to WebAssembly. And that's what you have to do with WebAssembly modules. What's really cool about WebAssembly components is that if there is already a component that builds that library that you need in your ecosystem, instead of you having to build that one in, you can link to it with your code. And there's a lot of reasons why I find that really exciting. You can do things like principle of least authority, where I no longer have to give ambient authority, or basically think about it this way. Imagine everything that gets your keys for your DynamoDB database and your messaging broker and all of the other different types of systems and API keys that you have. You define those maybe with operating system variables, and then you say, in today's world, you just say, okay, app run, and then all of your third-party dependencies, everything that's part of your current supply chain, that 85% of the code that's not yours, somebody else's, and hopefully you audited and vetted all of it, but if you didn't, a bad actor somewhere in your supply chain could say, oh, well, I might be the most popular message broker library that people use, but I also wouldn't mind knowing the AWS API key for somebody's database. And so with components, I only have to pass in exactly what it says it needs to run. And so we're building this new software foundation of building blocks that let us build software in a safer and faster way. So I think that's really, really exciting. And so why I would build a chart for, hey, what are these top dependencies? It's so that people will be able to join after this event, after we have this hackathon. They'll be able to join and start building with components and build on the components as if if I gave them a bucket of Legos and said, here you go, you can already go ahead and start with these. And the even more exciting thing is, hey, you can go ahead and start with these, and you can write in a higher level language like JavaScript that you already know, because there are tools like JCO, JavaScript component tooling, that let you take JavaScript and compile it to a component. So take a language that you already know, but take advantage of these other languages that compile to super tiny WebAssembly components because they're written in languages like Rust and C++, more systems level languages, and so you can eke out every bit of performance out of them.
Aruna, would you mind if we address one of the comments I'm here in chat?
Yeah, I mean, I was about to actually go there. There are wonderful comments coming along. So Taylor Dolezal, who we all know. Hi, Taylor. He's saying, howdy, folks. Looking forward to see this session and happy to see many familiar faces. I'm going to
Yeah.
keep rolling. Hi,
Uh,
Andre.
Chris Chris Mosino, I think, made a great comment. He says, the biggest advantage from user experience is the ability to engage from virtually any modern device with a browser without having to search for or download native apps, updates, push instantly to all users, and performance feels native because it is. Pulling from 5G or Wi-Fi 6 can make the applications feel immediate and local. And I think, Chris, why your comment jumps out at me so much, and I think it's part of the reason why we see WebAssembly growing so quickly is that Assembly addresses the largest market in the world, which is just the bare compute needs of companies everywhere. Because regardless of what industry you're in, what WebAssembly solves for you and helps to make easier is universal. If you're building in industrial systems or financial services or medical devices, you all have a desire to build applications and experiences that are natively mobile first, that are real time, that are available 24/7, that are increasingly personalized and proactive and enriched by AI and ML on the edge. And that means that we need to build new experiences faster on a vast and larger array of CPUs devices, operating systems. Bailey, earlier you described the web browser itself as the final edge, and it probably is the most popular deployment footprint in the world out there. But right adjacent to that is going to be all of the Internet of Things that dominate our lives in our pocket. Sarvjeet asked a great question, Bailey, around security concerns. Would you mind maybe speaking to some of the security concerns around WebAssembly?
Certainly. So
How do we know we're getting trusted?
WebAssembly,
How do we know if we're getting trusted Lego blocks?
there's a lot there. Before a lot of the work that's happening in the Bytecode Alliance, there are ecosystems that sign their WebAssembly modules, like Wasm Cloud. We sign the module, and we include all of the things that we knew it was asking for, like what types of imports from the host runtime does it need to be able to run. And so we prevent types of privilege escalation by doing a type of signing in that way. Now, the Bytecode Alliance, which is a software foundation that's working on building secure foundations just for WebAssembly, we're building I'm on the technical steering committee of the Bytecode Alliance, and so one of the major efforts that we've been working on is a registry. But it's not just a Bytecode Alliance registry, it is a protocol and a system for basically taking signed modules and moving them through a system securely, so that from first principles of the time that you've built this module and released it, everybody is able to validate those claims. And so that's one aspect of it. Another aspect is that a WebAssembly module is secured by the WebAssembly runtime. So the WebAssembly runtime could be a browser, but it could also be WASM-Time. WASM-Time is one of the runtimes within the Bytecode Alliance. WASM-Time is written in Rust. It's extremely tested. It's the runtime that's used in a number of production use cases. And one of the cool things about it is that it's the thing that provides the instance of the WebAssembly module. So even when you download a WebAssembly module, before you ever run it, you can actually verify it. That's one of the interesting properties of WebAssembly that a lot of people don't realize, is that I can crack open a WASM module and prove that it is not allowed to reach outside of its linear memory. So this entire swath of OWASP top 10 in a lot of ways don't apply to WebAssembly applications because of the nature of just, if you are able to compile it to WebAssembly, you know that it doesn't have things like double after free or the ability to reach into somebody else's stack. And that's a really powerful property for something that is so tiny that you can also sandbox safely.
I would pick up on that, Bailey, and maybe add that WebAssembly has not just embraced, but it's led the sort of modern evolution of capability-driven security. Now, maybe there's some old Linux gurus out on the call today, folks that have used like sudo setcap on Linux to give a normal system user maybe privileges to read directly from a network card or something like that. But if you're watching this in Chrome right now, for an example, just click on the lock next to Restream and then click Site Settings. And what you'll see is a example of capability-driven security for each website. And you're familiar with this on your iPhone or on the modern Mac OS X or here in Chrome, for example. When an application wants to use a specific capability, it starts in a deny by default sandbox, right? I don't have access to this particular file or to your camera or to your microphone. This movement and adoption of capability-driven security is one of the most important things to happen in security, and it's just sort of happened natively in the background on all of the platforms. What WebAssembly gives you, starting with first principles, is deny by default sandboxes. And as we mentioned earlier, rather than the monolithic ABI approach that you would take with like a POSIX or something along those lines, even the ABI that you're building on itself is a small a unit that we refer to as a WebAssembly component that's defined in a standard that's called WASI, WebAssembly System Interfaces. And much like you would find in POSIX, you have a set of common capabilities emerging in WebAssembly that define things like WASI sockets or WASI clocks or blob store, things along those nature. So it gives us an approach to the ecosystem and to software that really starts by thinking about security first. So when I think about coming back to the question, which was the security concerns, are that WebAssembly raises the bar entirely, even for code that wasn't designed with WebAssembly in mind. Just the very nature of bringing it into the WebAssembly sandbox gives you significant value props that can be further extended by open source platforms like CNCF Wasm Cloud, which is sort of like a WebAssembly shovel. You know, it's a tool and a community that's designed to help developers get into WebAssembly faster, adopt WebAssembly more easily, and scale some of the enterprise value props.
Beautiful. Let me take the next question by Taylor. It says, which is very appropriate. What do you feel is in a very mature state with WASM? And what do you feel needs more focus, support, or contributions?
So the WebAssembly core specification is stabilized. It's standard. You probably are using it multiple times a day if you're using Google Meet or Zoom or Prime Video or Disney Plus. It's everywhere. You just don't know it. Open up F12 and search for .wasm, and you'll probably find at least one throughout your day. The things that are especially stable within that are also the languages that compile to that core spec. So there's a toolchain called Emscripten that was originally created by Alon Zakai. I gave him a shout out earlier about ASM.js. From the very beginning, Emscripten initially produced ASM.js, and now today it can produce a WebAssembly module that runs with JavaScript glue around it, and that's great for running in the browser. The places where I would say there's a significant call to action is adding standards so that we have standard interfaces that runtimes can expect and need to implement so that I can portably run a WebAssembly module that says, hey, actually, I compiled to this world that is a CLI world. And in a CLI world, I expect things like a file system. I expect to be able to maybe have access to a socket. I also want to be able to pass in standard in and standard out, so I want to do some standard I/O. So those types of things are what's happening within the WASI working group. So that's a great place for a call to action. I think that we're reaching a level of stability there where we'll bring tool chains forward into building on top of that, and then we'll reach a level of stability with that. The other places that I think are really exciting is finding ways to embed WebAssembly. So, for example, one of the use cases that I used to work on was taking WebAssembly and embedding it in the query processing engine of a database. Because if you think about it, WebAssembly is a sandbox, and so I can safely run it inside the same process that's executing my DB engine and be able to do things like user-defined functions and run arbitrary code or run machine learning and run stuff that I wouldn't normally be able to write in SQL, or it'd be very frictionful to write in SQL, but a lot easier to write in something like Rust or Python. So I think finding good ways to embed runtimes like Wasm Time is a great place that is stable, yet a good place to have a call to action. And there are a number of different projects that I see happening, like with Exosysm. I see just within the Wasm Time project itself. There are other runtimes like Whammer, Wasm Edge. There's interpreters like WASMI. I feel like the innovation space right now around just building runtimes is really huge. And so if folks are interested in that level, especially if you're into compilers, having multiple different compilation targets, like I want to be able to basically be able to do an interpreted mode so that I can start quickly, but then do a multi-phase compilation pass so that I can eventually get to ahead of time compiled machine code. All this to say, there's a lot more that we could do to make WebAssembly even faster than it already is today.
You know, Bailey, I think you gave an incredible answer for the developers on the line. And I want to do an additional call to action and say that, you know, WebAssembly is one of those wonderful communities that has room for all sorts of personas to come and help. In fact, we have an event coming this early September. Bailey and I call it Bacon. It's the Bytecode Alliance Con. It's on the Friday after WasmCon, which is the Linux Foundation WebAssembly event that's coming up on September 6th and 7th in Bellevue, Washington. You can find that if you do a quick Google, or maybe we can put some notes here in the show link. And at Bacon, we're doing an event called Componentize the World, where developers can come together and take libraries from many different languages and turn them into Lego blocks that are reusable by anyone in any language in WebAssembly using WebAssembly components. And there's also going to be lots of opportunities for non-developers to help thinking about examples, writing documentation, maybe creating images to help explain concepts. WebAssembly, like a lot of great communities, is powerful and growing quickly because of its broad adoption, because of the diverse membership and participants that all bring radically different use cases. That's what really makes WebAssembly great today, and that's going to continue, Taylor, to be what makes WebAssembly great in the future.
Fantastic. And Billy, the point that you were making earlier, to that, Chris also posted a comment. This will be transformative for interactive entertainment video games. Finally, because one click, many devices, massive player base. So even though originally WebAssembly was declared as the fourth language of the web, but is no longer restricted to web, it's just like pervasive, going anywhere and everywhere, and is a massive expanding base.
One of my favorite examples of that for the video game industry is that as a gamer myself, I also really enjoy modding my games, but it's a little spooky downloading some DLL from some random site and then that's running and installed on my computer. So one of my favorite examples of this is Microsoft Flight Simulator. Actually, instead of adding modding support traditionally, like by being able to add and let other people run DLLs in the system, they added WebAssembly to their game, and that let people build things like this Ukrainian bomber that has different types of like little meters with the like spin wheels and stuff, and be able to animate all of that in a unique way to kind of give a more immersive experience. And so that's just another one of those examples where I really feel that WebAssembly is the last plugin model you'll ever need, because when you're writing plugins, right, those are arbitrary things coming from other people somewhere randomly on the internet, and so I need them to be sandboxed, but I also need them to be fast. I also need them to be pluggable and hot swappable and all of those types of things, and WebAssembly is just perfect for that use case.
Beautiful. I think we'll keep moving and I'll go back to the questions here. You talked a lot about WASI, you talked about components, and this goes takes me back to the tweet that Solomon Hykes, the founder of Docker, did. And he said, if WASM plus WASI existed in 2008, we wouldn't have needed to create Docker. And you've talked a lot about how WebAssembly is not just for web, but it could pretty much be everywhere. Talk to me about this premise of WASM plus WASI as opposed to Docker and being very fit for edge computing and containers use case.
One thing I want to say there is it's not as opposed to Docker. Docker actually today runs WebAssembly runtimes natively. And so it's not wrapping them in a container that's virtualizing Linux. It's executing the WebAssembly runtime to run the WebAssembly module. So it's very tiny, low overhead. They're definitely a better together type technology. Now, I will say that WASI is very different, where containers focus on finding ways to virtualize Linux and the POSIX ecosystem. With WebAssembly and WASI, WASI is actually more about finding ways to expose modular and higher level interfaces. And so the types of APIs that you can provide are now really semantic in a way, because I'm passing in things like a key value interface. And inside my key value interface, I've got get set, and I am now able to plug in any other provider that matches that key value interface. So I can hot swap things in, like pointing to Redis or pointing to HashiCorp Vault. So it's a very different paradigm. Also, in your Docker container, you would bake in those types of capabilities. The WebAssembly runtime has to provide them in some way, but there's a lot of different flexibility that you can do to be able to provide it. It doesn't all have to be running within the WebAssembly runtime process.
Just beautiful.
Liam, I've heard him answer this one a lot better than I just did.
Bailey, I love it because I think that fundamentally we're different personas. You're the Cosmonic CTO. You are the on the TSC, the Technical Steering Committee for the Bytecode Alliance. You're co-chair of the W3C. You are in the weeds, and I love your worldview because it speaks very deeply to the developers to know that that you understand where they are, because you're the same persona. I think I would take a step back. And at the time the tweet was made, I think there was some unclarity if WebAssembly would just become virtual POSIX. And I think based on our experimentation, it's clear that by design, we're not going to be. And here's the way that I would think about it at the really high level. For all of those things that are already so tightly coupled to Linux, that are highly optimized to take advantage of Linux primitives or run on that specific environment, WebAssembly is not necessarily the greatest choice. Containers are what we have as a great abstraction for POSIX with C groups and namespaces together, and will continue to be. I don't think that, yes, there will be all kinds of stunt hacking. There already is. There's entire x86 virtual machines that run inside of WebAssembly. However, I don't think that that is the best use of WebAssembly. WebAssembly really shines when we think about the green field, about extensions, about plugins. And that is where today I see this better together story coming together. Now, maybe in the medium term, we might have a little bit more parity, or we might have the ability to do so. But for now, I really think that it is truly a better together story. And WebAssembly shows up and is compatible with your entire environment in the same way that you adopted first cloud native or public cloud, then cloud native and microservices. You just permissionally innovated through HTTP boundaries. WebAssembly typically serves via HTTP when you're thinking about backend and microservices. It doesn't always, and it doesn't have to. It's very extendable, but I think it's a great way to start thinking about how can I adopt WebAssembly today, and what are those great use cases to get us started.
Beautiful. Um, One of the things that I think about over the evolution of web industry is Node.js, came up with APIs that were incompatible with browser, and now reconciling some of that. And we see something similar happening in Vazi, where APIs are designed to work outside the browser without considering bringing these APIs to the browser in the future. What do you think about that? Is that expanding the scope of WebAssembly? Is that breaking the web? What do you think about that?
What's really cool about the component model and modular interfaces with WASI is that there's a technique that you can use. My team calls it WASI fills, which is a play on polyfilling. And polyfills is that I know what the API is, and so I can plug in something in the web when I'm running in an environment that, say, doesn't have a traditional file system. And there's a tool, I've already talked about it a little bit before, Jco. That's written by Guy Bedford, who works over at Fastly. He's built Jco, and he's also built this other piece called WASI-Vert. Both of those projects are within the Bytecode Alliance GitHub org. If you combine those two, you basically get superpowers of being able to run anywhere. It knows how to create the right basically glue that you need in the browser and the right stuff that you need when you're running server side. And so this is really powerful because it no longer means that I have to wait for every single runtime to implement the exact same ABI, and the ABI has to now move forward monolithically across everyone. Now I can add new APIs and try things out and start implementing right away, get feedback on how well that API is designed, and then have that feedback loop within the standardization process. And I think what that ultimately means is that we're going to start seeing this new type of WebAssembly component and interface definition that people are going to swarm, and then we're going to get a few that are just best of breed components that everyone enjoys building with versus the common denominator kind of, well, it's everywhere, so I might as well just use it type of software development that we have today.
Yeah, that makes sense, because what you're doing is you're really creating those markets which allows WebAssembly to be used everywhere, as opposed to be restricted by the. Sure, there is a common denominator if you want to run. Really depends upon your target audience, essentially.
That's right. Arun, you and I connected on this offline, but there was this epic ACM article that was written by Tom Killalay probably a decade ago now, called The Hidden Dividends of Microservices. And for ACM articles, it was quite short. It was maybe a full page. I encourage anyone in the audience to Google it if you're not intimately familiar with it. But it talked about why microservices really enabled an organization. And when I think about the WebAssembly component model, Bailey and all the incredible members across the Bytecode Alliance that are pushing forward this model, it really, to me, sounds a lot like the microservice approach to the application ABI. To give us the ability to decompose our primary application building blocks into smaller interfaces to enable the permissionless innovation and evolution of them independently, which, as we all know, innovation velocity is directly correlated to success. The faster we can iterate and build, the faster we can learn, and the faster we can move things to the next level.
That's beautiful. I'm gonna pivot. I know we have about 15 minutes remaining here, and I'm gonna bring Taisir's question, which is very much connecting to what I think. I'm a developer, and the only way for me to understand the advantages over anything else is through Hello World example. Show me what does that Hello World look like. Like, let's say I'm building a Spring Boot application. I'm writing a Rust Hello World application. How do I get started?
Well, I would say share your screen. Let's do the live demo. I mean, this is my favorite part of any call when we're going to actually dive into the tech. So I would say, Arun, do you mind being our guinea pig?
Okay, I will. I will ready to be a guinea pig. So what I'm going to do is I am going to share my terminal.
And to clear everyone, we didn't decide this until a minute before we went live, so this is very much a live demo. This is me, being the engineer in the room surrounded by crazy people, but it's okay. We're going to do it.
And this is where I want to take a moment, actually. I should have said this in the beginning of the call. Congratulations, Bailey, on your newly role of CTO. Tell us more about that.
Thank you. Yeah, I love Kevin Hoffman. He's one of the main reasons why I wanted to join Cosmonic. I've read his books. He's just brilliant, and I enjoy doing this side of the job, getting to talk to people and nerd out about WebAssembly with as many people as I can, and having a little bit more of a direct role over some of the innovation direction within Cosmonic was something that Kevin talked to me about and thought I could do. And so Kevin is going to continue leading in the chief innovation role at Cosmonic, and I'm going to be focusing on making the best distributed application platform there is for WebAssembly. And hopefully we can run it on your laptop today for the first time ever.
All right.
Look, I don't think just the laptop today. I want everybody at home to please open up a browser and follow along. I'm going to raise the stakes. Like, we work well because it's a nice seesaw between the engineering and the executive. Come on, let's do this. Let's do it live. Come on.
This is where the difference between an entrepreneur and a CTO comes in. I love that spirit. Okay. So,
Kapil Tanglu, the creative pod custodian, chimes in. Demo gods be kind. Yeah. So I'll
thank you, Kapil. Thank you for that tribute.
All right, so let's start by sharing your screen. Let's let the audience follow along with you here.
So I'm going to bring my screen here. All right, here we go.
And actually, let's open a web browser if we can. And I'm going to have you go to we could either go to cosmonic.com and just go right into our docs, or we could go to GitHub.
So let me show you one more screen then, which would be my, sorry, window, terminal.
Yeah, and this truly is the live demo. We actually just threw this out right before we hopped on the call.
So I'm sharing. It seems like I can share only one thing at a time. Is that so?
Okay, well, let's share Chrome. Let's do it all through Chrome.
So let's do all through Chrome then. So I'm going to go ahead. Let me open up a new tab first of all. There we go. So you want me to go to cosmonic.com? Let me go there, and then I will open up the cosmonic.com.
Sure. I think I did a commit at 6 this morning for this call today. You did. I was just inspired. The team checked in a neat way to launch an application right from a website. So I think it should all work just fine. Right. So let's click Docs. Let's go ahead and just click Docs. Okay. I'm going to take you in. I'm going to actually have you launch a specific Hello World. Because I know Taysir in comments asked, what's the quickest way to Hello World? And on the left, just go to Things to Build. And then there's this thing called an XKCD image generator right there. And then just click that button, Deploy on Cosmonic.
Okay. Give us the background, first of all. What are we doing here?
Yeah. So Cosmonic is a distributed WASM PaaS platform as a service. And by default, we can run your WebAssembly workloads for you. But what we'll show in step 2 here is that we can actually run WebAssembly and orchestrate it across any cloud or edge for you. And to be fair, Cosmonic builds on this incredible community in the Cloud Native Computing Foundation called WASM Cloud. So what we really deliver for you is the batteries included experience for WASM Cloud. And what this is simply going to do, it's going to take an application manifest, which is an OM spec, an open application manifest that says, hey, take these WebAssembly Lego blocks, take a web server Lego block, take a web client Lego block, and then run them for me automatically. And it'll also should, because you haven't logged into Cosmonic before, I don't think, it should also provision a whole private distributed WebAssembly constellation for you, which is, we wanted to think about why be stuck in the clouds when you could come to space. So hence the kind of space branding and theming around Cosmonic.
Okay. And these components, it doesn't matter what language they are written in. They're just seen
That's
as
right.
WebAssembly components, essentially.
That's right. That's right. And we're in the process now of deploying the WebAssembly component model. So that'll be going live here
That'll open up a
shortly.
new
The
tab for
ability to
me,
use
though.
additional
So should I be
languages.
saying different tab now?
No. So if you click the deploy on Cosmonic button there,
I did. It opened up a new tab for me.
Oh,
yeah. So we may need to share a different tab. I apologize. I'm not
That's
sure
all right.
about the
I can
restream
share a different
experience
tab. Give
here.
me a second here.
Okay. All right.
I'm going to go ahead and Cosmonic, and here we go.
And it should take you to a nice little space theme where you have the ability to log in, and go ahead and just click the launch button. And then what's going to happen automatically is you've built your whole WebAssembly PaaS. So think about the friction in deploying Kubernetes or any of the other technologies you would need. You can log in either with GitHub or Google. It shouldn't matter.
So
And
deploys Cosmonic.
Great. And you're going to land here on your UI. Now, in today's call, that's the command you can copy and paste into your MacBook there if you want to extend your cluster to your MacBook. And then you've created a self-forming, self-healing WebAssembly PaaS that's running on your MacBook and in Cosmonic Cloud, which runs on AWS.
So this is in addition to running in AWS, it's running on my MacBook as well.
That's right. If you type that command in and run it, but you shouldn't need to. If you want to just click I know what I'm doing, we can go ahead and walk you through this.
Okay, perfect.
So what you just did was you just linked to that application manifest.
I know what
there.
I'm doing.
Yeah, share. Yeah, go ahead. All right. So if you click on applications there.
And for all that matters, this is the first time I'm ever playing with this interface. I've never launched here, none of that. This is not scripted at all.
Yep. So click on applications for me on the left, if you don't mind. Let's see. It should bring up an application view for us.
Oh, here we go. Okay.
Okay. All right. Go back to the other tab and click the launch button again. That should then open up here for you and give you that application manifest.
Go back to the previous tab again.
Yes, please.
But that was the deploy on Cosmonic, though.
Yeah, click the deploy on Cosmonic button, and that'll go ahead and launch it here. I think when we clicked I don't know, we didn't click save and launch, so the manifest was on screen. Yeah, I just rolled this out at 6 this morning, so we're just getting going.
So I got a new view here. So let me go ahead reshare my screen again. It's a new tab. So let's go back here.
I see a question
if anybody's
about
sure,
also like to know about the async support. So right now, basically the way that async implemented is with callbacks. However, async support is part of our plan for WASI Preview 3. So we're rolling out WASI Preview 2 actively right now. Like that's why I'm scared of these kinds of things, and that I know the level of churn that's going into building out all of these different foundational pieces for Preview 2. Well, Preview 3 is going to be next year.
If you look at the manifest here, the details just specify OCI registries to download these various components. So there's 3 components that make up this application. If you click Save and Deploy in the top right, this will go ahead and launch this into your ecosystem. Now, if we go back to let's stop at the infrastructure view first. If you want to click there, I'll just give you a quick tour. Here in the infrastructure view, you can see you have one host that's managed in Cosmonic. And if we use that, the CLI command earlier, we can deploy additional Cosmonic hosts that will just show up here and extend your WebAssembly paths to include all of the capabilities that you have on whatever
So,
host.
so
So on my,
essentially, if I would have used that CLI, I would have created my MacBook as a host, and that would have
yep,
shown up in this interface.
that's right.
Yes.
If you look at our private chat, I just sent you the bash command if you want to run that. And after you run it, you can just type Cosmo up. And as soon as you do, a new host will appear
Got it.
here.
Got it.
And then if we go to the logic view, what we'll see is the various pieces of our application. Now, what's powerful is that we have a logic view for our app that's running. And let's go and make it live on the internet and let everybody at home see this. Let's click on the wormhole button there. And what that'll do is just create a public,
This one, HTTP
over on the left on the toolbar, the vertical toolbar in the middle.
logic infrastructure applications.
Just to the right of that, there's a wormhole button.
In the
Just to the right on the canvas.
Oh, this one.
I'll
Oh,
have our lock
yeah.
there.
Sorry,
Click
my bad.
that.
Yeah. Okay.
And you can just click create a wormhole. And this will just now take this application and put it on the web. It opened up behind the XKCD. So we have a little UI tweaking to do
It
here.
says wormhole damp darkness 5734 was provisioned.
Yeah.
Okay. Slide the XKCD box down on the canvas. The wormhole is there hidden behind it.
So you can
where it says
you can grab
it.
that. Yeah.
Okay. So now click on the wormhole, and what I'd like you to do is on the right, just click access your wormhole. Okay. And here, what we can do is, that's going to open up a new tab
so
for
let me
you.
go ahead and do the resharing again.
It is an XKCD comic, so double check that one is safe for work, and if not, refresh. Okay.
Yeah. And then what I'd love for you to do is to right-click on this tab and click Create a QR code. Because what I would like anybody watching at home to do, and I'll do it as well, is we've now just deployed a WebAssembly application that's running here on the cloud. And did the QR code come up?
Where do I create the QR code?
Just right-click or two-finger click anywhere on your Chrome canvas. And it should give you in the options when you scroll down, it should give you the ability to create a QR
Wait,
code.
so this is hold on. So
this is baked into Google Chrome.
Oh, baked into Google Chrome itself. Okay. So this is on the XKCD random comic page?
Yeah. What I would like everybody at home to do, anybody watching, is to be able to hit the application.
Here. Oh, create QR code. Okay, beautiful. Okay.
Okay, there you go. Share your screen again. And now anybody at home can take that QR code and they can hit it with their phone. And now you've created a WebAssembly application and it's live on the web
so
here. So so two-finger click there.
There you go.
Oh, we do. It's for whatever reason, Restream doesn't show it. I think it opens as maybe like a separate, like floating tab. So we don't actually see it on your screen. But if anybody wants to visit that QR code, or you could walk through those simple instructions yourself, you can just go to cosmonic.com.
Well, there's a link on the top anyway that you can take a look at then.
Yeah, but we've deployed this application, and over at Awesome Cosmonic, if you visit that GitHub repo, you'll see that there's multiple versions of this application. So if you deploy the second version, it will automatically distribute it across multiple edges. I'm going to push a third one after this call that will deploy it across all edges. So if you had 100 devices attached to your cluster, you could automatically deploy and orchestrate these WebAssembly components there. What's powerful about this approach is that these WebAssembly components can live on any of the nodes in the infrastructure, and you can pull them together to build these applications. So this is a very powerful use case for WebAssembly. It's designed to help developers build faster and to be able to solve their problems quickly. And Arun, this has been a phenomenal show today. We have to do another one. I mean, we only just got started and on WebAssembly and getting it going.
This is beautiful, actually. I really enjoyed this demo and the entire discussion around WebAssembly. Absolutely fantastic. So yeah, I mean, I would really encourage people to try out Cosmonic Cloud and get your first hand and feet wet as part of that. Thank you, everybody, for staying here. All right, bye, folks.
Bye, Arun. Thank you, Bailey.
Bye.
Thank you, Arun.